So we're looking at midterm 2 from the University of Washington's Math 120 course. This is the first problem from the winter 2016 exam. And we're looking at a situation of selling cakes. And we know a little bit about the way that our revenue system works. In particular, the number of slices that we sell per day is a linear function of the price. And we're given two particular price points. We know that if we sell cake at $1.20 a slice, we're going to sell 82 slices per day. And if we sell at $3.95 a slice, we're going to sell only 27 slices per day. And we're asked to do three things. First, model quantity as a function of price. This is the quantity sold per day as a function of price. Second, model the revenue. Again, this is revenue per day as a function of price. And third, to find the price that will maximize the total daily revenue. So let's dive right in. Parts A and B are relatively straightforward here. So for part A, we're asked to write a linear model here. We're told that this relationship is linear, and we have two data points. So we shouldn't have too much trouble actually modeling this. What we're looking for is something of the form mx plus b. And we know two data points. So this should be enough to solve for our two unknowns. We have two data points and two unknowns, m and b. So let's go ahead and solve for the slope. If we increase the price from 1.2 to 3.95, we decrease the quantity sold from 82 to 27. So this looks a little ugly. Let's see how it plays out. This is actually a little nicer than it looks. 55 is exactly double 27.5. So this actually turns out to be simply negative 20. Okay, well that's nice. We have m. The slope is negative 20. We can just plug into one of our data points to find b. Let's use this one. We have 82 is equal to negative 20 times 1.2 plus b. This is going to be negative 24. So adding 24 to both sides, we get that $106 is equal to b. So this should give us our linear model. We have a linear model. F of x is negative 20x plus 108. Let's double check that this feels about right. I do know that when I plug in 1.2, I get 82. And when I plug in 3.95, the math is a little bit ugly. If I imagine having plugged in 4, this would be negative 80 plus 108 is 28. But the difference between 20 times 4 and 20 times 3.95 is that 1 that's different here. So I like how this plays out when I plug in both of my points. So I have my solution to part A. So given the solution to part A, writing a model for revenue is actually quite straightforward. In general, I know that revenue is equal to the price per unit times the total quantity sold. In this equation we've written here, this function, we have x as representing the price per unit and f of x as writing the total quantity sold. So just multiplying through by x, here is a model for the daily revenue as a function of price. And now the last part of this question asks us to find the price that will maximize the total revenue. What I can see here is that this is going to be a parabola. In particular, because this coefficient is negative, it will be a downward-facing parabola. So the way that I maximize the price is by choosing the price that lands at the vertex of my parabola. So how can I find the vertex of my parabola? My preference is to find the vertex of a parabola by using some symmetry. I'll show you what I mean. So taking this equation here, I can rewrite it as negative 20x plus 108. What I notice here is that if this quantity is 0, then the entire value of g of x will be 0. Or if this quantity in the parentheses is 0, then the entire value of g of x will also be 0. So what I know then, because I know that my parabola looks something like this, if I find a value here and a value here that have the exact same y value associated with them. In other words, if I find some point g of 0 and g of something else that agree on their values, I know that my vertex will be right in the middle of those 2 points. So in particular, I can see here that g of 0 will be 0, and also if I choose x to equal 108 over 20. So in particular, my solution to part C, my vertex of my parabola, my profit maximizing price, is exactly in between 0 and 108 over 20. In particular, that will be at x equals 108 over 40. So I now have my solutions to my 3 parts. I have a solution to A, B, and